Welcome to the deep dive. You've handed us a fascinating set of sources today. It's less like a typical report and more like a mathematical detective story, a really deep forensic analysis of just one number.
That's right. The number is 24257.
Right, 24257. And the whole idea here is to test this hypothesis you've mentioned. Is this number just, arbitrary? Or is it what the researchers are calling a structural anchor for a whole numerical system?
Exactly. Is it just a random integer, or is it a kind of gravity well that organizes everything else around it? That's the core question.
So our mission is built around three key things you shared. First, the number itself.
24257.
Second, this very specific sequence, a linear recursion. Was it xn equals 3 times 2 to the n minus 319?
Yep, that's the one. And third, a very particular data set. It contains exactly 73 data pairs that come from that sequence.
And our goal is to, I guess, move beyond just the arithmetic. We're using algebraic number theory, some statistical forensics.
To isolate what's deterministic, the mathematical why, and separate it from what just looks like, random noise or what the sources call stochastic anomalies.
Okay, let's unpack this. And we have to start with the anchor itself, the number 24257. The first surprise is that it's not a prime number, which I think a lot of people might guess.
No, it's not. It's a semi-prime. And for you, the listener, a semi-prime is just a number that's the product of exactly two prime numbers.
And that's a critical distinction, right? Because semi-primes they're foundational to a lot of modern cryptography.
They are, especially RSA encryption. So finding out it's a semi-prime is the first big clue.
So we have to find the factors. What are they?
The fundamental identity is that 24257 equals 127 times 191.
Okay.
But the real elegance here, the beautiful part, is what these factors actually are. They are not random primes. They're intrinsically linked to binary arithmetic.
Which is the engine of the sequence.
Yeah.
The 2 to the n part.
Exactly. The whole system is speaking the same language.
So let's break that down. Start with 127.
127 is famously a Mersenne prime. That's a prime number that has the form of 2 to some power minus 1. In this case, 127 is 2 to the 7th power minus 1.
So one of the core building blocks of our number is literally generated by a power of 2. It's like its DNA is written right there.
It's the algebraic equivalent of having the family name written on the foundation stone of a house. Yes.
Okay, so the factors are telling us that 242CE7 is fundamentally binary. What about the other one, 191? Is it just as structured?
It is. 191 is also a prime, and while it's not a standard Mersenne prime, the analysis shows it's a variation of a related type called a Fabit number.
It's a Babbitt number.
Right. It can be expressed as 3 times 2 to the 6th power minus 1. So again, you have that power of 2 right at its core. Both factors are defined by binary operations.
This is where it gets really interesting for me. This is where that structural anchor idea starts to feel less like a theory and more like, a fact. Let's talk about the constant in the sequence, minus 319.
Yeah.
That number, 319, it just looks like an arbitrary subtraction.
No.
But it's not. It's a bridge.
The coherence is stunning. It really is. You take the two prime factors we just found, 127 and 191, and you add them.
Okay, so 127 plus 191 is 318.
318. Now add 1.
You get 319.
Next.
Wait a second. The constant, 319, is the sum of the prime factors of 24257 plus 1.
Yes. It's not a random shift. The sequence is being shifted by the shadow of its own factors. 319 is this partition that connects the number's multiplicative structure, the factors, with the sequence's additive structure, the constant.
That is almost too neat. Why the plus 1? Is there any chance this is just retrofitting a hypothesis?
That's a crucial question. The plus 1 often represents closure or, boundary conditions in number theory. But the real proof that this isn't a coincidence comes from where the number actually lands in the sequence.
Okay.
Your source material confirms that 24257 is exactly the 13th term.
X13 is 3 times 2 to the power of 13 minus 319.
And that equals 24257 for yes. Precisely. The number is mathematically anchored at index n equals 13. That constant, 319, is what forces it to land right there. The system is completely self-referential. It's deterministic.
Okay, let's shift to the sequence itself then. We know it's exponential. It's just going to shoot straight up. But the sources point to some fascinating structure right near the beginning.
We're looking at the zero crossing, which is just the point where the sequence flips from negative to positive. And that happens between n equals 6 and n equals 7.
What are the terms right there?
Well, at n equals 6 by 6 is minus 127.
Minus 127. That's the negative of our first prime factor.
That's it. Right as the sequence is about to be born into the positive numbers, it briefly is the negative of one of the factors of the number it's designed to generate.
That can't be a coincidence.
It's pure number theoretic structure, and it goes deeper. At n equals 7 by 7 is 65. The source focuses on this observation that 65 minus 17 is 48.
Okay, that subtraction feels a bit random. Why is a difference of 17 important?
Because 48 is the pure exponential term, 3 times 2 to the 4th power. So by 7 is 17 units too large to be a simpler power of 2 function. And why 17?
Well, 17 is also special.
It is. 17 is a fermat prime. For you, the listener, a fermat prime is a prime of the form 2 to the power of 2 to the n plus 1. They are incredibly rare.
So you have a fermat prime appearing right next to a negative Mersenne prime, right at the zero crossing.
It's like finding a cosmic signature. It confirms the whole system is operating with this very specific language of number theory, all based around powers of 2.
Let's talk about constraints. The data set is exactly 73 points long. Does the number 73 have any mathematical meaning here?
The sources ran a modular analysis to check for what you might call resonance. First, modulo 3. Every single term in the sequence is 2 mod 3.
Meaning none of them are divisible by 3.
Exactly. The sequence is engineered to avoid multiples of 3. But now, modulo 73, the conclusion is concrete. No element in the sequence, no matter how far out you go, is periodically divisible by 73.
So the data set is, as the sources say, free of resonance with its own size.
It's like the system is deliberately set up to be mathematically sterile relative to the sample size. It avoids interference. It's an incredible level of control.
Okay, this brings us to the hardest part of the sources, the statistical anomalies. You pointed out that the listener observed a singularity, a clear V-shaped minimum in the data at index 42.
And this is the moment of contradiction. Because we know mathematically xn is an exponential function, it only goes up. It can't have a V-form minimum, especially not way out at n equals 42.
So that observation has to be noise or something else is going on.
Something else entirely. The V-form only appears if you shift your perspective. Instead of plotting the value of xn, you plot the deviation from the anchor, 24257. So the absolute difference, xn 24257.
Ah, okay, so that value would go down as you get closer to n equals 13, hit 0, and then go back up.
Exactly. The mathematical minimum, the V-tip, is perfectly at n equals 13.
But the observed statistical center was at 42. That's a huge gap, from 13 to 42.
And this is the absolute key to the whole thing. The source calls it the lag hypothesis. The discrepancy between the mathematical center, 13, and the observed statistical center, 42, is exactly 29 positions. 42 minus 13 is 29.
29? Okay, wait. I feel like that number is... It feels familiar.
It should. Go back to our constant, 319.
Yep.
That number, the one that bridges the factors to the sequence, the factors of 319 are 11 and 29.
No way. The positional lag, 29, is a prime factor of the additive constant.
Yes. The system is correcting for itself again. The apparent statistical anomaly at index 42. It's not random noise. It's a lag, a positional offset of exactly 29, which shifts the mathematical center at 13 to the observed center at 42.
The circle is closed. The noise is the structure.
That's it. It's a direct deterministic consequence of the sequence's own constant.
Profound. Okay, before we get to the final implications, we have to touch on the listener's other question about a symmetry between index 5 and index 58.
Right. And first, we rule out any real mathematical connection. Algebraically, there's nothing there. By 5 is a small negative number minus 223. By 58 is, it's enormous, approaching 10 to the 18th power.
So they're not equal, not congruent. The link isn't in the math. So where does it come from?
The sources conclude it's an artifact of external data organization, a coincidence.
Something like how a database was structured.
Exactly. The sources mention financial indices, asset allocation series. It's very likely that the entry at index 5 just happened to be linked to the entry at index 58 for some external, non-mathematical reason.
A crucial distinction. Our brains want to see patterns everywhere, but this one isn't real.
The math proves a link between 13 and 42, and it flatly denies one between 5 and 58.
So let's broaden out. What are the statistical implications here? Let's start with Benford's law, that leading digits should mostly be ones. How does this sequence do?
Well, exponential sequences like this should obey Benford's law, but only as the numbers get very, very large. Your sources found a big statistical abnormality in the first 73 data points, especially in what they call the transient phase, for n less than about 15.
And why is the beginning so chaotic?
It's that constant again, minus 319. For small values of n, the exponential term is tiny, but the big negative constant dominates the whole calculation. So for by 4, it's 48 minus 319, which is minus 271.
So the constant is just throwing off the leading digits at the start.
Precisely. The leading digits are disproportionately 2s and 3s at the beginning, so the data set is not homogeneous. You really have two different populations. A chaotic beginning driven by the constant, and then a clean, ordered exponential tail that starts to behave itself once n gets past 15 or so.
This all sounds so designed. So what does this incredible coherence actually mean in practical terms?
The biggest implication is cryptographic. We know 24257 is a semiprime, the kind of number used for RSA keys. The fact that you can generate this specific semiprime with such a simple deterministic rule,
From by 13.
right, that poses a theoretical vulnerability.
Because if an attacker even suspected that a key was derived from a simple sequence like this,
It would dramatically shrink the search space. Instead of having to test trillions upon trillions of factors, if, the number might be the 13th term of a simple structure, you just have to test maybe a few hundred possibilities. It turns an impossible problem into a manageable one. It's a potential backdoor.
So this deep dive, it really does prove the initial hypothesis. This isn't a random collection of numbers.
Not at all. It's a highly deterministic system. It's driven by the interaction of powers of 2 and Mersenne arithmetic. And the things that look like statistical anomalies, like that V-form shift, are actually direct, predictable consequences of the system's own DNA.
A completely ordered world just hiding behind a mask of randomness.
And that leads us to the final thought for you, the listener. The key finding was that the prime factor 29, a factor of the constant 319, perfectly explains the positional error, that 42 versus 13 lag.
Meaning the statistical noise isn't noise at all.
It's a closed-loop feedback mechanism. The system's hidden complexity is literally encoded in the simplest, most boring-looking part of its own equation.
So for you, the takeaway is never trust the appearance of randomness in structured data.
Always look for that hidden numerical offset, that factor of the generating constant that connects the messy statistical observations back to the clean underlying algebraic DNA. What other systems out there might be revealing their deepest secrets through their noise?